Yes, members?
Yes.
I think that was clear, not so?
It's supposed to be 7, 9.
Hey, after rounding off, correct rounding off, good. Correct rounding off. Let me write it well. Speed is equal to 8.2279 meters per second. Ask me if there's any question, please. Any question? That question is clear, right? Members? All right. There's this one here. Let me check this one. Which year was this? There was this one. I feel like I should also give you. By the way, we are through with projectile, but the only thing we are left is just calculations now. Okay? Just doing as many examples as possible. So now we have seen when the object is projected from the ground. Now let's see when the object is projected from what? From a given point. Let me leave you with one question that you can work on it. One question under this one. Revision question. Revision what? Question. This one I've just got it randomly. Did I say a projectile? The question is a projectile is fired from ground level with a velocity of 500 meters per second. With a velocity of 500 meters per second at 30 degrees to the horizontal. 30 degrees to the what? To the horizontal. Full stop. Find the horizontal range. Comma. The greatest height. Attained. The greatest height attained. And time taken. To reach the greatest height. Time taken to reach the greatest height.
So I'm not seeing.
You're not seeing? Is it okay now?
Yes.
Okay. That was, let's say this is B. Let's put part B. What is the least speed? What is the least or minimum speed with which it could all be projected in order to attain order to attain the same horizontal range. Same horizontal what? Range. Are we together? So for part B, let me just give int for part B. Int. So when you look at that question, part A, I think we can all do that. It's straightforward. But part B, there's some kind of reason you have to put in, because they're saying what is the least or minimum speed to which it could be projected in order to attain the same horizontal range. To attain the same horizontal what? Range. So what do you think we need in that? What do we need? What aspects should you put together so that you can answer that question well? Members, because they're saying to attain the same horizontal range, the one that we are going to get in part A. So what should be that speed? That minimum speed? Yes, Sandra? Sandra?
Yes, teacher.
What do you need in that question, part B? What do you need in part B? What do you need to answer that question, part B?
They're asking for that speed.
If they're asking for the speed, but there's some few things I want you to put into perspective. Not just a matter of getting speed. Okay? Not just a matter of getting what? Speed. Because I say what is the least? The key word here is what? Is what?
The least.
The least. And that same speed, that least, that smallest or minimum velocity must give us the same what? Must give us the same range. Which means range must be what? Maximum. Which means range must be what? Maximum. Because if we are using two velocities, which is going to give us the same range. Two different velocities to give us the same what? Range. Which means that distance, that horizontal distance must be maximum. That horizontal distance must be what? Maximum. Which means if it's maximum, which means what? How do you get? Which means you must know how to get maximum what? Maximum range.
Maximum range.
And we said maximum range occurs when what? What's the condition for maximum range? Which means the angle of projection must be what? 45?
45 degrees.
So which means you are going to say from maximum what? Maximum range, which is equals to, we got what? Was what? What was the formula?
U squared over G.
Over what? Over D.
G.
So this is the speed they are asking for, this one. Okay? So if R max is maximum, is what? Maximum, then U must be what? Must be what?
Minimum.
Must be minimum. That's a simple logic in mathematics. We have seen this. Those are things you must analyze. If this one is maximum, this one must be minimum. Okay? Yes. So this is the equation you are going to use, which means you are going to say U minimum, U what? Minimum is going to be
minimum.
Is going to be R what? RG.
RG.
The square root of RG. Not so? Is equals to the square root of R max. What? Have you seen that? Members, are we together on that? Sandra?
Yes, teacher.
Have you got that? Have you got it?
Yes. Good. Yes.
Okay, now let's look at a situation where an object is projected from a given point above a ground level. We have seen how we do calculation when an object is projected from a given point above the ground. We have seen when it's projected above a ground level, when it's directly vertically projected up. Now this time is projected. Is what? Is a projected, which means it must be projected at a given angle to the horizontal. It must be projected at a given angle to the what? To the horizontal. So is that the same case? It's just the same case. Nothing much will change. Okay? Are you together? So nothing much will change. So the only thing you have to take note of, let me sketch it from here. Above, ground what? Ground level. When the body is projected. So take for example, we have a cliff there. We are here. That point. So this is the ground level. The ground level. This is our ground level. So the body is projected here. This is the given height. The height. Let me call it H. So the body is projected from this point, okay? The body is projected from this what? From this point. So which means it will follow the same path like we have been doing. It will follow the same path like that. I think that. So within our initial speed will be there, will be tangential. That is still our U. This is still our angle projection theta. So we can still have two components there. Can still have two components there for velocity. You can have that. And you can just have this. Have you seen that? So this one still remain U sine what? Theta. This one is still U cos what? Cos theta. So now what else? Is there anything new there? Is there anything new there? Is there anything new there, members? So let's look at example number 1. Let's look at example number 1. Let's look at example number 1. So they're saying a particle is projected at an angle of elevation of 30 degrees with a speed of 21 meters per second. If the point of projection is 5 meters above the ground, find the horizontal distance that the particle travels before striking the what? The ground. Before the particle striking the what? The ground. So which means they're just asking for the range. So they're asking for this distance here. They're asking for this. What's our range? Okay? Before striking the horizontal distance, the horizontal distance, the particle must travel before striking the ground. Because when it strikes the ground, the horizontal the distance become now this one. It becomes from this point up to here. I think that. But now they're asking for before striking the ground, which is this. Which that's our range. Members, have you seen that? Yes. So that is method 1. That is method 1. So the one which is ux is equals to ut equals that, which we can find that. That one is very clear. We have seen how to find horizontal distance. Then for that one, we have all seen all those. We have seen all those, which is clear from there. Or we are saying you can use the equation of trajectory. Just a matter of applying those formulas. Just a matter of applying those formulas. Are we together, members? Are we together? Steven?
Yes, teacher.
Are we together?
Yes.
Yes. So that's a matter of playing around with those formulas. Even the same applies in question 2. Just a matter of going around with those formulas. So finding this horizontal distance. That's a matter of playing around with those formulas. What about when the object is being projected and horizontally from a given height? This time is being projected what? Horizontally. How does that one look like? Let me see. So the body is projected horizontally. This one is horizontally. So from a given height here. So which means the velocity is going to be what? Running horizontally. The velocity is running horizontally because the body is projected horizontally. It's projected horizontally. So which means it will move like this. It will what? Move like this. So this one we can normally see them in with the jet fighters, if they are throwing bombs. Okay. So you find the plane will continue. The jet fighter will continue moving horizontally. So this is our initial speed. So at this point, the angle projection is what? The angle projection theta, angle projection, angle of projection theta is what? Is 90 what? Is 90 what? Is 90 degrees because it's running horizontally. It's running horizontally. Then this one still remain our range. This one will still be our range. That horizontal distance x, we can call it x, we can call it range. Are we together, members? Are we together on that? Sandra?
Yes.
Are we together?
Mm.
Yeah. Good. So the angle of projection will be 90 degrees to the vertical, but to the horizontal, because I remember telling you, the angle of projection must always be to the horizontal. The angle of projection must always be to the horizontal, which means if the angle is 90, this 90 is to the what? This one is to the what? To the vertical. But to the horizontal, the angle of projection theta will be equal to 0 degrees to the what? To the what?
Horizontal.
To the horizontal. Take note of that. Sometimes they confuse with those. Take note of that. Take note of that. So just using equation, how we get distance. Here the most thing you must apply is how we get distance, how we get velocity, which we have already discussed all of them. That one will be just waste of time. We have seen how we get direction because it's a velocity and it's a vector quantity, which means you must know how to find the direction. As simple as that. Members, any question? Any question? Yes, please. So now the task you have, the task you what? You have is to go to question bank and look for question under projectiles and do them. But I've simplified. Just go to the website and download for me this book. Download for me this book, okay?
But it's not there.
It's not. It's there, Sandra. It's there. Can I show you?
Yes, you show me.
Okay. I'm going to the website. Huh?
Mm-hmm.
Are you seeing my screen?
Yes, I'm seeing.
Thank you, Sito. Thank you, e-learning. Have you seen it there? It's there. Remember what?
Login.
So I will log in. Still loading. Let it pass load. So for me, I will put mine is please don't copy my thing, eh? Let me get there. David Watmon. The password. Have you seen that?
Yes.
Now I will go to Now I'm logging in. Let it pass.
Mm.
So you come to the menu.
Menu.
Right? You come to the menu. Then under what?
Resources.
Resources. Resources. You go to notes and exercise. Are you seeing it there?
Yes.
There we go. Let me search for it. Physics. You can see. Are you not seeing? Even it's just here. Even it's here. A-level physics mechanics. Are you seeing it there? This number 2 here.
Okay, for me, I've been looking for it from the
Study material.
resources, and I don't. Is it the first one which you did? Not from here.
Now you have seen, eh? Yes, you go and download that book and you go through it. Okay?
Yes.
But what is important, now you have the concept. We have the concept, right? Yes, the most important thing in physics is the concept, because once you have the concept, you can manipulate any information that is given to you. Okay?
Yes.
So when should we do a test on projectile? Because we have from today up to Friday, up to Saturday, sorry. So when should we do a test? I want to give a test. And the test we are going to do is among these questions. You go and download the book. So you revise all these questions you are seeing here. All these unit question past papers are put there. Have you seen those past papers are put there? I will set question from there. Have you seen that?
Yes.
So go and download the book. Is there? It's not very big. So this one is containing. This book is containing all the topics in paper 1. All the topics in paper 1. Okay? Yes. So let's agree. When should we do that test? Can we do it on Saturday next week? Yes? People are quiet. Sandra,
Yes.
when should we do the test? Can we do it on Saturday next week?
I don't know, because my subscription is getting done soon.
Your subscription is almost expiring.
Yes. On a Tuesday.
On Tuesday. What about for Stephen? What about you, Stephen?
Yeah, any day.
Any day. Okay, now, okay? Let's make it like this. So when we meet on Saturday, try all your level best by Saturday. Okay?
Try all your level best by Saturday. Okay?
Pardon?
Saturday.
Pardon?
Saturday.
We're going to do the test on Saturday. That's the information.
We're going to do
now.
the test on Saturday. That's the information now.
Okay.
Yeah, but the notes are different.
The notes are different.
Yes, the notes are different.
They're different from this one I'm using.
They're different from this one I'm using.
Yes.
No, Stephen, you're lying. You're lying. Let me even download for you, and here you can see. Let me download for you.
Let me even download.
Are you seeing that? Okay? I'm downloading it. I'll finish downloading. Hey, it's different.
Yeah.
Yes. Yeah, they are different.
Hey, I'm going to upload this one. Okay? Let me upload it. It's not difficult. Just that one, just in a second it will be done. Okay? So I think let's stop there. So next time when we meet, we shall look at vector and scalar quantities, okay? Composition and resolution of vectors, okay? Now we're on chapter number 3, chapter 3. Members, do you have any other question for me?
So are you able to download this lesson on YouTube?
Yes, it's very possible. All these lessons, we are having out there on the YouTube, on our YouTube channel. Just go and say thank you to e-learning. Okay.
All right. Yes.
They will display for you all the videos. But the most important thing is I want you to have these notes so that when we come, I just explain the notes, okay? So that we don't take a lot of time again writing down the notes, okay?
Like when we come back to school.
No.
Yeah.
Okay. Okay, members. Have a nice day.
Likewise.
Be blessed.